we're going to use these U charts for when the subgroup size varies. And notice how right here we are essentially standardizing for sample size by putting it right there in that denominator. If you compare the denominator for the C chart and the U chart, for the C chart, when sample size is constant, it's going to be G in the denominator, and here it's sample size. So if you kind of wrap your mind around what is the denominator, it'll help you to understand. So let's do an example together. We're talking about the count of nonconformities. That's this column. There are 20 nonconformities in a sample size of 352. So you divide 20 by 352, it's going to be 0.057. See how we get U? It's a simple C divided by N. What kind of nonconformities might you find on a potato? Bruising, you might find some with the stem still on and it didn't, or there might be dirt on one. Maybe one got a scrape on it. If you're really interested, if you are like a French fry fanatic, you can look up the USDA has all these grades for French fries and all the defects or nonconformities that you might find. So here we're saying this could be 10 potatoes each with 2 nonconformities. They might have a bruise and a scrape. Or it could be 5 potatoes each with 4 nonconformities. See where I'm going with that? Let's calculate what the center line would be for this example. We just got to make sure we get these denominators right. This is the sum of N. This is the sum of G. We want to be doing this one. And so we want to add up all of the counts of nonconformities. And it's just 20 plus 17 plus 20 all the way down to 17. And for that one, I got 476. And then for the sum of the N, we're going to add up all of these N's. 352 plus 325 plus 354 all the way down to 327. So what that looks like on paper is 476 divided by 8314 equals 0.056 or 0.57, depending on how that shakes out. Okay, so let's turn that into an upper control limit. Let's do the upper control limit for the first subgroup. So the formula is U bar plus 3 times the square root of U bar divided by N of the ith subgroup, in this case the first one. So depending on what your number was up here, if you're using a calculator with your fingers, I put in 0.057. So, and then for this N, we put 352 right here because the sample size of that first one is 352. Since we just got the upper, I think we can forego the lower because it's just subtracting that entire term. So let's move on here. And what you'll see here in the PowerPoint is the solution. And you can imagine if you had a spreadsheet, you could just do this by just getting that formula right and dragging that down until the last subgroup. When we put those limits on a chart, it's going to look like this. So pretty good, huh? It looks like it's in control. Now, going back to what we were talking about last week, do you see any patterns here? So you're looking at this, you're out in Oregon or Idaho or somewhere. That's why they call it Ore-Ida French fries, where I used to work. It's right on the border. Some people from Oregon would tell you they make more potatoes than Idaho. It just depends on how you count potatoes, I guess. Do we have 2 populations here? Not really, because 2 populations would look like a bunch of points up here and a bunch of points down here, and not much in the this zone right here, right? Do you see any cycling? It's going up and down and up, like a bicycle pedal, up and down and up and down. Maybe a little bit. You're kind of like, why? That's weird. Or it just might be natural variation, you know? So that's, if I'm looking at this, I'm going, well, maybe here it's going up for about 5 points. And then it goes down for 2. So it's hard to tell in this case. Typically the cycling is going to look like this, up and more, it's going to be more exaggerated. It might look like a heartbeat or something like that. Does it look like it's increasing over time or decreasing over time? Not really. And then that last trend that we were talking about is, do you see any jumps, whether it's a jump up or a jump down? Not really, is there?